The equation y equals to a over x plus bx squared. Now at the point 3 minus 15, where x is equal to 3 and y is equal to negative 15, we have negative 15 is equal to a over 3 plus b multiplied by 3 squared. And from this we can obtain equation 1, which is negative 45 equals to a plus 27b. Now, we need to solve simultaneous equations. So in order to solve for a and b, we need to obtain another equation. So for that, we make use of the derivative dy over dx, and we'll get negative a over x squared plus 2bx. By solving it, this is what we'll get. Negative a over x squared plus 2bx equals to negative 13. We substitute the values of x at this point, x is equal to 3, and we'll obtain negative a over 3 squared plus 2b times 3 equals to negative 13. And from this we'll get our equation 2, which is negative a plus 54b equals to negative 117. So from these two equations, by solving simultaneously, we will obtain our values of a and b. And here we go. Substituting equations 1 and 2 together, we obtain b is equal to negative 2 and a is equal to 9. As for the next part of the question, we need to show that it has the same gradient as the point at point P. So by using the derivative that we found earlier, at x is equal to 1, substitute values in, we obtain this. dy over dx is equal to negative a plus 2b. And we also substitute the values of a and b, which we just found, into the equation. We'll get negative 9 plus 2 times minus 2. We get minus 13. Now this is exactly what we're given the question, to show that it has the same gradient. And this will wrap up our solution for part A. We shall now go on to part B. Okay, as for part B, it is a very similar way of solving. We start off with the curve, and by using the coordinates given to us at x is equal to 1 and y equals to 3, we have 3 is equal to a over 1 plus b times 1. And simplifying it, we'll have our equation 1. And same method again, we'll find the derivative of this curve. Okay, and we have negative a over x squared plus b. And at this point where x is equal to 1, we substitute the value of x is equal to 1, and we have dy over dx is equal to negative a plus b. Given further that the gradient of the line y is equal to 2x plus 1 is 2, okay, and it is parallel to the tangent at this point where x is equal to 1 and y equals to 3. So we have dy over dx, which is equal to negative a plus b, is equal to 2. And from there we can have our second equation, which is negative a plus b equals to 2. And applying the same method again, we solve simultaneous equations 1 and 2. We have 3 is equals to a plus 2 plus a 2a is equals to 1, and from there we find that a is equals to 0.5 and b is equals to 2.5. And here's a solution for both parts a and b. Thank you.